If you don't like panicking over space stuff, but you absolutely love a good mystery, then you've come to the right place. Every so often, an image surfaces from the depths of space that sends the internet into a frenzy. It's usually a grainy, fleeting glimpse of something that defies easy explanation, captured by one of the many robotic eyes we have pointed at the cosmos. These images spark our deepest curiosities and, let's be honest, some of our deepest fears. They make us ask the big questions. Are we alone? And if not, what are they doing out there? Well, get ready to lean in a little closer because it's happened again. Something zipped by the sun. A strange, linear object, impossibly fast, cutting a path right through the fiery, chaotic atmosphere of our star. It's the kind of image that immediately gets labeled, shared, and debated across countless forums and social media feeds. The speculation runs wild, from secret government spacecraft to, of course, the ever-present possibility of an extraterrestrial visitor. And before the official explanations can even be drafted, the court of public opinion is already in session. So, what are we looking at? Is it a glitch in the matrix? A natural phenomenon we just don't recognize? Or is it something more? We're about to unpack it right now, piece by piece, using the same methods scientists use to separate fact from fiction. But, first, and this is the most important step, breathe. Take a nice, deep, calming breath. This isn't an alien suicide run, seriously. While our imaginations love to jump to the most dramatic conclusions, the universe is filled with phenomena, both natural and technological, that can look incredibly strange to the untrained eye. The path to understanding begins not with panic, but with a healthy dose of skepticism and a clear process of elimination. So, let's start that process. To understand what we're seeing, we first need to understand we're seeing it. This image comes from a solar observatory, likely a satellite like SOHO, the Solar and Heliospheric Observatory, or one of the stereo spacecraft. These incredible machines are our sentinels, constantly monitoring the sun. Many of them use a special instrument called a coronagraph. A coronagraph is essentially a telescope with a built-in sunshade. A small, precisely placed disc, called an occulter, blocks the blindingly bright main body of the sun. This creates an artificial eclipse, allowing the telescope's sensitive camera to capture the sun's much fainter outer atmosphere. The corona. It's in this ethereal million-degree plasma that we see these strange events unfold. But these cameras are not like the one in your phone. They are highly specialized scientific instruments, operating in one of the harshest environments imaginable, the vacuum of space, bombarded by radiation. And that environment can cause some very weird things to happen. The most common culprit for these fast, straight streaks is a tiny, invisible particle that's a constant nuisance for space imaging, a cosmic ray. Cosmic rays are not actually rays, but high-energy subatomic particles, mostly protons and atomic nuclei, that have been accelerated to near the speed of light by distant supernova or black holes. Space is absolutely saturated with them. When one of these energetic particles slams into a camera's digital sensor, a CCD or CMOS chip, it deposits a huge amount of energy in a single pixel or a small cluster of pixels. This overload of charge then bleeds down the column of pixels as the sensor is read out, creating a perfectly straight, bright line in the final image. It looks like a physical object moving at impossible speeds, but it's just an electrical ghost, a momentary scar left by a particle that was never really there to be seen. Most of these fast streaks are camera glitches of this exact nature. But cosmic rays aren't the only ghosts in the machine. These observatories generate a colossal amount of data, far too much to transmit back to Earth in its raw form. So, the images are compressed. Think of it like turning a huge, high-quality photo into a smaller JPEG to email it. Sometimes, this compression process goes slightly wrong. A bit of data can get lost or corrupted during the long journey from the satellite to a ground station. The result can be a processing artifact, like macro blocking, where parts of the image appear as chunky squares, or strange, misplaced lines that appear out of nowhere. These are not objects in space. They are errors in the data itself, introduced during image compression or transmission. Now let's move beyond glitches and consider real objects. The space around the sun is not empty. It's a cosmic graveyard of comets. So-called sun-grazing comets are balls of ice and rock whose orbits bring them perilously close to our star. As they approach, the intense heat and radiation cause them to vaporize violently. What we see in the coronagraph isn't the comet itself, which is usually far too small. but the massive glowing tail of gas and dust it releases. This can look like a bright streak or a smudge moving through the corona before it completely disintegrates. The SOHO satellite alone has discovered thousands of these tiny comets, many of them meeting a fiery end. So, a tiny comet vaporizing in the sun's glare is a very real and very common possibility. And then there's our own stuff. The region of space between the Earth and the Sun is getting crowded. We have thousands of active satellites, defunct probes, and countless pieces of space debris orbiting our planet and the Sun. Sometimes, it's a human-made probe passing through the telescope's field of view. An Earth-orbiting satellite might cross the path between the observatory and the Sun, appearing as a quick, straight line. Mission planners know the orbits of all our spacecraft, so identifying these is usually a straightforward process of checking orbital data. It can even be something much closer to home, the satellite's home, that is. A tiny fleck of paint or a micrometeoroid impact fragment could be floating near the observatory itself. If a piece of debris is caught on the edge of the camera's view, drifting slowly just in front of the lens, it can appear as a blurry, out-of-focus object moving against the backdrop of the distant sun. So, with all these possibilities, glitches, comets, satellites, debris, how do scientists figure out what's what? They don't rely on a single image. The key is verification. The first thing scientists do is check multiple telescopes and observatory feeds worldwide. We have a fleet of solar observatories, including SOHO, the Solar Dynamics Observatory, SDO, and the twin stereo spacecraft. Each has a different perspective and different instruments. They meticulously check the timestamps. Did another instrument see the same thing at the exact same time? They also dive deep into the engineering data, examining instrument logs to rule out real objects. These logs report the health of the spacecraft, the camera's temperature, voltage fluctuations, and any recorded errors. A spike in the radiation environment monitor at the same instant a streak appears is a dead giveaway for a cosmic ray. This cross-referencing is the heart of the scientific method. If multiple independent instruments separated by millions of miles all see the same object from slightly different angles, then it's real. This effect, known as parallax, is crucial. A nearby object will appear to shift its position against the distant background when viewed from two different locations. A distant object will not. If an anomaly appears in SOHO's data but not in stereo's, it's almost certainly a local effect, like a cosmic ray or an instrument glitch. If it only shows up in one camera on one satellite, and the instrument logs show no unusual solar activity, and no other observatory saw anything, the conclusion becomes clear. It's probably just instrumental noise or a processing glitch. It's not the exciting answer, but it's the one that fits the evidence. So what would real evidence of something extraordinary, something truly, look like? First, it would have to be seen by multiple independent sensors. Second, it would need to exhibit behavior that defies our understanding of physics. A real object, whether it's a comet or a satellite, follows a predictable path dictated by gravity, known as a ballistic trajectory. It can't just stop on a dime or make a 90-degree turn. If we saw an object that demonstrated controlled, non-ballistic motion, like accelerating against the sun's gravity, or executing a sharp, intelligent course correction, that would be astounding. That would be a discovery that would require immediate, rigorous, and public peer review from the global scientific community. It wouldn't be a mystery debated on forums, it would be the headline of the century. This brings us to a practical point for all of us who love these mysteries. When you see a viral clip of a UFO near the sun, how can you assess it for yourself? First, check the source. Is it from an official NASA, ESA, or university feed, or is it from a YouTube channel known for sensationalism? Second, look for corroboration. Have other official sources posted about it? If it were a truly significant event, every major space agency would be talking about it. Third, be patient. It takes time for scientists to download all the data, cross-reference it, and come to a conclusion. The first explanation you hear is often just speculation. The real evidence-based answer comes later. So, what's the bottom line on this latest streak? While it's dramatic to watch and it absolutely fires up the imagination, the overwhelming probability is that it's something perfectly ordinary, just seen in an extraordinary place. It's a reminder that the universe is a complex and often messy place, and our instruments, as amazing as they are not perfect. These events are usually harmless, a part of the daily noise of doing science on the frontier. Want updates on this specific event and others like it? The best approach is to follow the science. I'll keep a close eye on the official feeds from the solar observatories and the agencies that run them. When they release their analysis, I'll report back. In the meantime, stay curious, stay skeptical, and never stop looking up. The universe is full of real wonders, and we don't need to invent new ones to be amazed.